Okay, welcome back to Scientific Computation using Python. This lecture I want to show you animation, how to do animation using matplotlib. Animation helps us visualize dynamic processes. It can be very useful in some research or your projects. So let me begin. We have another import line with the function animation function. Before that, let's put the regular import lines. Import numpy and matplotlib. Import matplotlib pyplot splt. After these two lines, we have a new import line to do the animation, and that is import matplotlib animation. Import this as animation. Most of the time people import it as animation with a capital A. Okay, now once we have the import line, next we define a function, animate function, and then it returns some value. I will just put it in a moment. And then to start the animation, we have animation.funcAnimation. So this therefore, any animation that you are going to do will have an animate function that updates the animation, and then where you actually create an instance for the animation with this line here. The parameters are, you need a figure as a parameter. So this is the window that will be animated. An animation function or an update function. So this animate is this function over there. The name can be different if you like, but animate is good for us. And then an update interval, 100 will be 100 milliseconds update to that window. Therefore, when I write 100 there, it means 100 milliseconds interval. So if you want to update the second, you put 1000 there. And then if you are working in a Windows environment, you can also use blit parameter to make your animations smoother. So blit will make the animation more smooth, but it does not work on a Mac environment, for example. Therefore, I say if you are using Windows, it's always good to have blit true. So this is where you create the animation by supplying a figure, animate, update function, an interval in milliseconds, and to make it look nice and beautiful, write the blit, set the blit parameter true. Okay, at this point you would realize that figure, there is this underline over there. It's warning me that I didn't define a figure yet. So figure is undefined. Okay, I need a figure for my animation. Therefore, figure and then axis. I have introduced this command in the previous videos. I will use the same idea, subplots. So PLT subplots returns a figure object and an axis object. Okay, after the subplot, I say x dot plot For x values I supply an empty list, for y values I supply an empty list, and then a O parameter, because I simply want the data points. I will actually animate one single point on the screen at the beginning. So this plots a data point, and I want to assign this to another variable, a point variable. And for some reason, to make it a tuple, we need a comma over there. That will become obvious as we proceed. So let's now, before I do the animate function, let's set the limits, so that let's set the y limits also like that. So my x limit and y limit from 0 to 10. Okay, now to repeat what I am doing, I want to create an animation. I need a figure, so this stuff over there is actually the place where I define my figure and set various parameters. I also define a point variable that is going to hold my graphics that will animate. Okay, inside the now let's move into animate function. We usually use a variable, any variable there, and then after the return line we put the graphics that is going to be update itself. So and inside the function we write the dynamics, the mechanics of our animation. But for now, let me just put print I. Okay, let me just put print I. So my update will just print the I. I is an automatic variable that increases every time, every interval update. So let's run this. One thing that you need is your graphics to be printed, to be drawn outside this graph. So I put matplotlib. Now I am ready to run the animation. Let's see what happens when save it and then run it. Okay, now as you see, the graph doesn't update because I didn't really do any graph related points here. But as you see, my I variable where I printed here is updating. In other words, my animation is running, it is ready to run. So I can now begin to update my graphics. So how do you close this animation? I learned that you have to close it, close this window. Otherwise, if you try to close it somewhere else, you will have a problem. So let me stop it here. Okay, so the animation stopped. As you see, so the print line over there. If you want to test, for example, a faster interval, now this is 10 milliseconds. Let's see how that runs. So as you see, the intervals go much faster. Okay, let's stop that. Now I want to update my graphics. So you work this way: point dot set x data, and then you need to set the x and y data. So how about we x and y? How about we just put random numbers for x and y? A random number between 0 and 10. I will do something more useful in a second, but I can begin. Okay, So inside the animation function, every time, every interval, let's make the interval a little longer. So that's a quarter second, 250 milliseconds. I am setting a random number. I am setting a random number between 0 and 10 to the x coordinate, and the same to the y coordinate, another random number to the y coordinate. Let's see what this looks like on the animation window. Okay, this simple animation, you can see I is increasing every time interval, and then you can see the point moving around. So the most basic animation to see how everything works. Let's close this. Again, you can make it slower by increasing the interval. Let's have a look once more. Okay, so the update is slower now. Okay, let's do something more useful. I would like to move the point around. In order to do that, I want to define my x and y outside. So let's start at the center, because my limits are 0 to 10. So these are my x and y coordinates. Now I define them outside the function. So remember, the variables inside the function are different than the variables you define outside. To override this, to override it, I need global definition at the beginning of the function. So this is to say that this function will be using x and y. It may change them, and the global variables also change. So when you make it global, then how about we do something like this? Increase x by 0.1, and then y, I won't change the y. Let's look at this function again. I initialize my variables there, and I increase the x every time the animate function runs. It runs, in this case, let's make this half a second, 500 milliseconds. Let's run this and discuss what we see. So as the point moves, I see that dot on the graph also moves. Let me close it. You can also print x and y or anything you want in the function. Let me run again. So you can see it's I, x, and y as the animation moves forward. If you are not happy with this representation, of course you can always do something like this. So that's an integer, and then you want, for example, 2 decimal points for your numbers. Okay, this will format it in a much better way. Every time the interval is passed, the x value increases. Okay, I don't really need this print line, so I want to take it off. You will see the animation works properly without the print line. The point is y. Okay, How about we also change the y as well? So y update, but let's move it a little slower on the y-axis. Okay, so it's also moving up. Okay, and then let's make it a little faster. So what happens when the point crosses the boundary? Well, we won't see it once it crosses the boundary. So what we can do, we can make it return, turn back, or appear on the other side. So how about we do, to make it appear on the other side, I can write an if condition here. If x is greater than 10, then x is equal to 0. And the same for y. If y greater than 10, y is 0. And now I want to make my animation even faster. Now this boundary conditions, when it disappears from one side and appears on the other, is called cyclic boundary condition. Okay. Next, let's try something like this. How about we move randomly on the screen dx a random number and then dy a random number. And then I can make it because the random number can be, because the random number here is between 0 and 1. If I subtract 0.5, I have a random number between minus 0.5 and 0.5. So look, in this case, every time my particle will move to the left or right with different amounts. So let's run this. Okay, and now when it goes out from the left, I can make it appear on the right. How do I do that? You can also write these lines on a single line. If x is greater than 10, then it's 0. If it is less than 0, then it should be 10. And the same. I want to do this for the y. If y is greater than 10, it is 0. And if it is less than 0, it is 10. So let's run this again. So if it moves out of the screen, it should appear on the other side. And it wouldn't. Okay, there. Yeah. How can I make it a little more smoother? I can make this dx smaller. So that's the steps. I can make it 10 times smaller. I can make them 10 times smaller, and then make the interval also smaller. So the update is 5 milliseconds now. In other words, this is 200 hertz, 200 times a second. Okay. Do you want to see what happens if you blow a wind? How do you do that? How about I also at each step I say x is x plus 0.1. So this is like a bias line. Let's see, what do you think about this? What do you expect this will do to our animation? Let's run it. Oh, this is too fast. I want to do something like this. So this is like a particle trying not to blow away with a constant wind. I can make that wind even slower. Okay, now this gives you the opportunity to play with it a little bit. Okay, the most basic introduction. Before I finish this part, I should also try to set the size of my point, for example, to a larger one. I think it is marker size. Okay, and then you can make it larger. Okay. And color. There are other options you can also try. Also, let's do a diamond. Okay. This is good. Now let's do something more interesting. Okay, now let's instead of one particle, let's do multiple particle animation. It won't be much different from what we've done already. Here, say I have 5 particles. Their initial positions are random points between 0 and 1, and so these are random numbers between 0 and 10, and I want 5 of that. If you want to see that, look, numpy random gives you a random number. This gives you a random number between 0 and 10, and then this one gives you 5 of those numbers. So putting instead of putting 5 here, I want to be able to change them at a later time. So I want to make this n. Okay. Therefore, each one will move different steps. So I have them here, and the update line will be the same. I want to get rid of this at first. So let's see how this runs. I changed the marker size, etc. here. So let's run this. Now you can see I have 5 particles moving randomly. As you see, when it goes out of the border, it doesn't come back because I removed those lines. So this looks nice. I want to increase the number of points. So still the animation moves very smooth. I can make them larger. I can put more particles. And for this time, let's make the marker a little smaller also. Okay, you can try yourself how much more you can go. Now I want to do the boundary conditions. This is how I do it with the NumPy arrays. This time the coordinates are in NumPy array, so this is how I do that. X is the coordinate, so look what x looks like. So if I say x is greater than 10, that will be true for some of the particles that are beyond the border. So x greater than 10, so I write it this way. X will be 0 for those elements that have that are greater than 10. If they are smaller than 0, then they will be 10, appear on the other side there. The same goes for y. Python NumPy arrays make you write this in a very short, nice way. So here, let me read this. Set the X array elements to 0 that are greater than 10. Set the X array elements to 10 that are less than 0. And likewise for Y. So let's see how this works for 15 points, for example. Run. Okay, now as you see, when the particle moves out, it appears from the other side. You can see it there. Okay, I want to conclude this part with this animation and move to do something more.